isometric switches first, or isometric contractions. And it's really important to think about the terminology here. Iso means same, so the prefix iso means the same. The word metric means length, and you're going to want to write that down. It's going to really help connect the meaning of this type of contraction with that term. So same length, and that is when the load is too heavy to be overcome. Okay, the length of the muscle remains constant. The contractile elements contract, but the amount of tension that is being generated is not enough to overcome the load, right? And you can see at the bottom here, load is greater than tension. So what we see is that there's a stretch provided by the series elastic elements. In other words, the tendons stretch, but the muscle does not actually shorten. Okay, and so the load is not lifted. Let's look at it here, and then I'll show you a more practical example with my bar again. So we've got this muscle that's suspended here on this force transducer. This is the muscle in its relaxed state. We've also got it hooked up to the simulator apparatus, and that is going to mimic the firing of an action potential to stimulate this muscle. And so because it's being suspended, the same way that our muscles are suspended across a joint by two bones in our bodies, we're going to see that when we stimulate this muscle, we see that the muscle contracts, right? We can see that it goes from a relaxed state here to a contracted state here, but we don't see our transducer move, right? It doesn't move because these series elastic elements, so the white parts at the periphery here, which are the tendons, they go from the shortened phase here to this stretched out phase here. And so while the muscle contracts, the series elastic elements stretch, and so nothing moves. Everything stays the same because the change in the tendon size compensates for the contraction of that muscle. In other words, the load was too heavy to be overcome, right? It was too heavy for us we were not generating enough force for that load to be overcome. If we look at the graph here on the right, we're comparing the tension or force being generated to the time here. And what we see is that we start out with our latent period, then we start generating force, go all the way up, and then we reach the peak of our contraction, and then we level off. Right? So there was never a time where the curve flattened off, because there was never a time where we were providing enough tension to actually overcome our load. And so the muscle is just going to do what it naturally does, generate as much force as it can, and then gradually level off. Now, kind of switching gears to a more practical explanation of that. Let's say I'm trying to lift this bottle, right? So I'm trying to lift this bottle. I'm contracting my muscle, I'm squeezing my muscle, I'm squeezing all that I can. I'm generating as much force as I can. And the tendon is stretching, my muscle is contracting, but the load is not being moved, all right? And so that's because no shortening is happening in the muscle, because whatever contraction is happening in the body of the muscle is being compensated, or it's being canceled out by the stretch of the tendinous parts of the muscle, the series elastic elements. Okay. And so a simple way to explain an isometric contraction is if you're trying to lift something heavy, you're generating the force to do so, but the load is just too heavy. Okay, so no shortening actually happens. Let's move on to look at an isotonic twitch or an isotonic contraction. And again, thinking about the terminology here, iso meaning same, tonic meaning tension. This is where we're generating the same tension. Here we will see that because we are providing enough tension to overcome the load, there's a point where we can flatten off that amount of tension because it is enough to overcome the load and we don't need to provide any more, okay? Looking again at our little apparatus here, we've got our muscle suspended on this, this apparatus here. It is hooked up to a load, all right? We're gonna stimulate it, which is mimicking an action potential. And what we'll see is that it's going to go from its relaxed state to its contracted state but now we're producing enough tension such that the load can be overcome. And so we're going to see our transducer move as the load is actually lifted. We can see the load go from this lower position all the way up to this higher position because the muscle actually shortens. And when it provides enough tension to shorten, enough tension to lift the load, we don't have to increase the tension production beyond that point. All right, so looking at our curves again here on the right, we see the shortening, the amount of shortening of that muscle. So we start off with 0, and we can consider this an isometric part of this contraction. Once we start providing enough force, we have an isotonic contraction that is able to overcome the load. Comparing that to the tension production here, so this was the amount of shortening, this is the actual tension being produced. We again start out with the latent period, we're generating force, we're trying more, generating more, generating more, generating more, and then we get to a point where we can overcome the load. So we find a sweet spot where we're producing enough tension to actually lift that load off of this transducer. And so at that point, we no longer need to increase tension production. And so we can flatten off this curve, flatten off this value, right? Flatten off the curve here, which is the amount of tension being produced because we have overcome the load. Okay, and this is why we call this an isotonic contraction, because for the remainder of the peak of the contraction, we're at the exact same amount of tension because it is enough to overcome our load. All right. And so this can be described as a contraction where there's enough of constant tension to overcome a load because the tension is greater than the load, and the load can be lifted as the muscle shortens. All right, moving on to a more practical illustration, if you will. So again, I'm trying to lift my water bottle. I'm producing force, producing force, producing force, and I'm actually able to overcome that load. My muscle shortens, and I can provide the same amount of tension for a while because it is enough to overcome the weight or the load of this bottle. Right? And that is an isotonic contraction. Okay. Any questions before I keep going with this? All right. So what we have here is a scenario that kind of explains the difference between isotonic contractions and isometric contractions, because isotonic contractions usually are preceded by isometric contractions, okay? So if you're trying to lift a load, there is a period at the beginning of that contraction where you're not producing enough force just yet. We consider that an isometric contraction. And then eventually you do produce enough force, and that would be an isotonic contraction, and you can actually lift that load. So we're starting off here. Let's say that we have a muscle. The maximum amount of force that this muscle can generate is 17 grams, okay? So this muscle cannot lift a load that is any heavier than 17 grams. So we're gonna start out trying to lift a 5-gram load, okay? Now, because 5 grams is a menial amount when compared to 17, we're gonna lift that load with ease. We're gonna have our latent period. We're going to flatten off because we generate 5 grams worth of force, and so we can overcome a 5-gram load. And so the tension remains the same for a period, and then we relax. This is an isotonic contraction. We were able to lift that 5-gram load. Let's move on. Let's move on to a heavier load. So now we're looking at a 10-gram load. Okay. Again, we're going to initially have our latent period. We're going to generate enough force. Now we're seeing that we require a little bit more force because this is a heavier load. So we're now going to go from 0 grams or 0 tension here all the way up to 10 grams worth tension or force. And then we're going to flatten off because once again, we've generated enough tension to actually lift a 10-gram load. So we flatten off. And again, this is considered an isotonic contraction because we were able to lift that 10-gram load. We then relax and we start again. Now we're looking at an even heavier load, so 15 grams, right? This is getting closer to our maximum amount of force generation, our maximum tension production, right? But it is still within that amount. So we can generate enough tension. It may take a little bit longer, right? We're gonna have to raise the force a little bit higher. We now generate 15 grams. We're gonna keep that tension the same because it is enough to overcome that 15-gram load, and then we're going to relax, okay? Now we get to a 20-gram load, okay? And a muscle that can only produce 17 grams worth of tension or force cannot possibly lift a 20-gram load, right? There's just no way. So this is going to be considered an isometric contraction. We're going to start out with our latent period. We're going to start generating force. We're going to generate 5 grams worth of tension, 10 grams worth of tension, 15 grams worth of tension. We're going to generate 17 grams because that's all we got. That's all that this muscle can generate. And then that will still not be enough. But because that is all that we can generate, we're eventually going to just flatten off and then relax. And so this type of contraction, as we'll see, the load was never lifted because the load is greater than the maximum amount of tension that can be produced by this muscle. All right, just to really reiterate this difference between an isotonic contraction and an isometric contraction. So once again, isometric meaning same length, muscle doesn't shorten, load is not lifted, the load is greater than the tension, okay? Practical example, you're trying to lift a heavy box of books, it's just way too heavy, your muscles are contracting, but it's not enough to lift that heavy box of books. Versus an isotonic contraction, same tension, this is where you can produce enough force to lift that load. And so the tension flattens off when it is achieved, and then we can overcome that load. So think about me trying to lift something light like this water bottle. This is an isotonic contraction. I can produce enough force to actually overcome this load. And so my muscle will shorten and actually lift the load. Before we move on, I do want to point out here one interesting connection is that as we can see, as we generate more and more and more force, as the load gets heavier, the amount of time that we can sustain that contraction gets shorter, right? If you're lifting a piece of paper, right? Lifting a piece of paper, or lifting a really light plastic cup, versus if you're lifting a really heavy load, you're not going to be able to sustain that contraction for a very long time, right? So if I'm lifting a lighter load, that's about 5 grams, I can sustain that contraction. Oops. I can sustain that contraction for a longer duration. But if I'm lifting a heavier object that's producing more force, I'm not going to be able to sustain that contraction for as long. All right. Okay, any questions about that so far? Okay, now just to kind of add some more details to the isotonic versus isometric, some contractions can be purely isometric, i.e. you're trying to lift a really heavy load, you never generate enough force to actually lift that load. But a purely isotonic contraction is rare, right? Usually, if you're trying to lift a load, there's a period with which you cannot lift it. You're still generating the amount of force that's required. And so that would be initially considered isometric. And then eventually you produce enough tension or force and you do overcome it. And then that would be isotonic. So it's hard to find a purely isotonic contraction. They are usually preceded by a period of isometric contractions first, but it is very easy, or it's more common to see purely isometric contractions. That is if you're trying to lift a 300-pound set of dumbbells, you can never actually provide the amount of force to lift that load, and so that is purely isometric. Okay. So even if the load is constant, isometric contractions typically precede isotonic contractions. In other words, there's a period where you're trying to produce the amount of force that's required, and then you actually do produce the amount of force and can overcome the load. Okay. Now, the load is generally not constant. So although we're talking about a load as being a set amount of grams, the load as it is appreciated by the muscle typically changes. So for example, if you're carrying groceries, the way that your muscles appreciate that load, if you're carrying them by your side, is probably heavier than the way that your muscles appreciate them if you're carrying them over your back. So the load changes as your limb positions change, right? So the load is generally not constant. And so the muscles are going to have to adjust or manipulate how much tension they're producing depending on your limb position, right? If you're carrying a load over your back, your muscle may not have to produce as much force. If you're carrying a load way out here, away from your center of gravity, your muscles are going to have to produce a lot of tension, even though the load is the exact same. All right, so your limb position changing can affect the load changing and eventually how much force is required to sustain